Okay, welcome back everyone. See here, actually I recorded that video, but I forgot to take my mic, so there will be some problem. So I am doing it again. So see, here what we had asked was there is a tapered cantilever beam like this. Okay, I am showing it with a yellow color right now. See, oh just leave it. I will do it again. Just a minute. Yeah. Okay, we have given with cantilever tapered beam like this. Okay, I will use different color to show it more precisely what we had been asked. No, this is not straight. Sorry guys. Okay, good. Okay, okay. Okay. So this length of the beam is 12. Let's say this plane A, B. Okay. What we had was just leave it. And the force acting here is P. I'm showing it with another color now. Force acting is P. What we had to find was find first. Just a minute. SFD and BMD. Just plot SFD and BMD. SFD and BMD. Okay. Then second was a good question. Find bending stresses distribution. Okay. Bending stresses distribution. Distribution. Yeah. Along length and depth. Along length and depth. Okay. So yeah, let us solve this. See. Here first SMDMD BMD we will draw. That's quite simple. We'll keep some place space over here for our calculation also. So this is let's see first SFD. SFD will be C. RA here will be equals to P for the equilibrium case. Okay. This is A point and this is B. And there is no force acting in between. So this will go a straight line. And here it is like this. So this is value is P. Okay. This is SFD. Now for BMD, consider like this. It's point A and point B. और जस्ट एक मिनट, ये थोड़ा नेगेटिव में आएगा तो ऊपर ही बना लेते पॉइंट्स को. I will draw it with another color A and B. See, this will be something like this. From this to this and this to here. Please note this is a straight line. While drawing, this is थोड़ा वो तिरछा दिख रहा है लेकिन वो स्ट्रेट लाइन ही है. अभी समझो ये कैसे बना है. मैं अभी इसके बारे में थोड़ा एक बता देता हूँ आपको, लेकिन आपको सबको पता ही रहेगा, लेकिन मैं एक बता देता हूँ कि यहाँ पे निगेटिव कैसे है, यहाँ पे पॉजिटिव कैसे. ठीक है. नाउ लेट्स कंसीडर हियर. As per my convention, sign convention that I am using, the upward force is positive. So it's positive, and the anti-clockwise bending moment will be negative. So there, here its value will be minus PL. But no need to write minus because already we are showing it below the axis. So PL only. Okay. Now, but as you all know, dm by dx equals to V, and V is positive. Hence, the slope of this linear line is positive. This all, this is, you all need to understand. Okay. Now let's move further. Now we have to find a bending stress distribution along length. We will find out first. Length one is a bit challenging. See, now the cross section area at point A and B we have given with. At A is like this. This is A. This is 6A. And at B it was A and 2A. I have enlarged the 2A value, but consider is like a 2A. So if we go and plot a linear relationship for the height at any x, so h at any x will be 2A plus 6A minus 2A upon length is 2L here, that's, as they had mentioned, and x. So it will be 2A plus 2A upon L into x. We might say it as C1 plus Kx for timing. Okay. So this is done. Okay. Now if we recall the flexure formula, sigma is equals to my by I. So m here in this case will be m is equals to p into x. I am taking x here, direction x. Okay. P into x. Y will be h by 2. And I, as you all will know, h cube into a upon 12. As a is constant, thickness of that frame is constant. So h cube a upon 12. Okay, now if we go and put it here, so sigma is equals to p into x into h by 2 upon h cube a upon 12. Okay, so what we will get 6px upon ah square. And we, if we go and put the value of h over here, so we will get 6px upon a into c1 plus kx whole square. Now the sigma variation will be proportional to x upon c1 plus kx whole square. Rest other terms are constant. So this is how it will vary. So this is difficult to plot. So we will just keep it till here. Now along the depth, as we know, this can be considered as the neutral axis over here. And if we consider any section, this will be, I will use another color. Upward side will be in tension. Okay. And then bottom side will be in compression. Simple. Okay. So this is how, and this is a neutral axis NA. This is h by 2 पे है ये, and this is also h by 2 पे है ये. ठीक है. So this is how bending stress will vary along the depth. And one more question they had asked, that was, just a minute. Yeah, here we will see. It was like this. They gave three diagram. I will use a yellow color here to highlight. First was the case we had solved here, like this. Second was like this. And third case was like this. Okay. Which one is good and why? So as we all know, the critical point in all and the loading is same. P, P, P. Sorry for the diagram. We all know critical point here is this and this. And the material mainly will fail in tension only. So tensile stresses will be dominating over here. So for the failure, the points are the top one points. So since, as we had seen, sigma due to bending is inversely proportional to height. So as the height increases, sigma reduces. Hence, the better one will be the first one choice. Simple. So this is how we had to solve this. Yes, so this counter questions are also done. Thank you.